Welcome, everyone. Thank you for joining us today. My name is Natalia Martin, and I'll be your moderator for this webinar. Today, we're presenting Engineering-Grade Security Enables Digital Transformation for Electric Utilities. Our panelists are Andrew Ginter, VP of Industrial Security here at Waterfall Security Solutions, and Bill McAvoy, Global Industry Principal for Power and Utilities at Aviva. A couple of notes before we start. This webinar is being recorded, and an email with the link to recording will be shared with all of you shortly following the event. There will be a Q&A session at the end of the webinar. Please submit your questions in a Q&A panel box at the bottom of your screen at any time during this session. We will try to answer all questions at the end of the webinar, but in case we are out of time, which happens sometime, we'll make sure to follow up with each of you individually and answer it via email. Now, Bill, turning the stage over to you.
Thank you. So good afternoon, all. Excited to have you here. So today we're going to talk about a couple things. I'm going to start out with just going over the actual digital landscape with a focus on Europe. And I will touch a little on North America also, just that's where I'm from and spent 34 years of my career there. And then I'll start getting into a little bit about digital infrastructures, digital transformation, some key things there, which is the reason why cybersecurity is so important. Then I'll turn it over to Andrew, who will talk a lot of focus on cybersecurity. So first couple things, as the energy industry, which today's focus, power and utilities, has been transforming and moving into this digital future. There's been a lot on cybersecurity standards. And this is nothing really new. These rules actually started back in 2014, actually. The first IT Security Act was passed, came in force around 2015. 2016 was updated with the new NIS2 directives. And actually, there's been some modifications since then. The key is to focus on making sure that cybersecurity across all industries, but of course, primarily critical infrastructure industries. So as the future has focused, and what we put in today's thing is, in today's abstract about our session, is the journey continues. So as I stated, it started back in 2014 with some reinforcements in 2015 and 2016. As you can see in this timeline, in 2021 and 2022, there's been some new directives, which were updated to actually do things such as include more significantly higher fines, making sure that there's a focus on security information, events management, just minimum kind of key components were continued to be evolved and enforced. So as we continue to move into it, there's a couple key things. This is to talk about CRITS, which is critical infrastructure. And that's kind of the term that's used specifically in Germany, as you can see, and across Europe. In German, the terms CRITS, K-R-I-T-S, means critical infrastructure. It's related to ensure that the protection involves critical infrastructure operators. So if I use the term CIO in the next couple of slides, I'm actually referring to critical infrastructure operators, not the CIOs as we know in organizational structure. Many countries, right, including Germany, have specific regulations and laws that protect critical infrastructure. As you can see here, I have listed the 10 primary critical infrastructure areas. And the whole concept here is that we want to make sure we protect the areas that could cause substantial shortages of supplies or disruption to public order safety. So as you can see in today's focus, number one there, we have energy because we feel that's critical. All else are also very important, but the focus of today is on energy. So as we look into what's happening now in 2023 to 2024, there has been an expansion of what KRITIS in Germany covers. There's new groups, additional obligations on the impacts, such as things like supply chain. Now, what's pretty interesting is, as I mentioned earlier, I've been working in Europe for the last 7 years, focusing on power and utilities, both in Europe and the Middle East. But I spent 34 years in North America working for a large utility. And as part of that, I was part of the NERC CIPs, which is the NERC Critical Infrastructure Protection Standards. They've been around for almost 15, 20 years now. The KRITIS here are following the same type of time frame and same life, I'll say, cycle and same maturity. As they continue to grow, they move in with additional requirements, additional fines, expanding what the scope could be. The key is always around reporting requirements, making sure that security measures are there, making sure that you're registered, that you go through a methodology to actually identify if you are considered a CIO in this area. These regulations continue to evolve and will continue to evolve as things go forward. And we thought it was important in this webinar today to set this standard and set the guidelines as we move through it. Now I'm going to shift gears a little, and I'm actually going to talk about what's going on in the industry, right? So in general, there's a lot of market pressures, right? So if you look at, while security regulations continue to increase, there are other pressures going on. So such as capital budget constraints. So as the new renewables and the new types of technologies get implemented to support the grid, there's still some capital constraints that have to be managed in the right balance. So things as putting in new renewables versus developing energy storage or continuing to put in larger new plants, those all have to be balanced. The concept of service disruptions and security threats, of course, we continue to see them grow over the years. And the industry also, which is very interesting, is a labor disruption. You know, many utility employees are 55 and over, being myself. As I mentioned, you know, I left after 34 years and still working in the industry, but in a different role, in a different environment, and actually a different region. But there is a lot that started that are in there. So as energy and utilities look at how they can manage going forward, things like digital transformation and technology is important to help fill in that gap. And then, of course, the drive to net zero, right? So not only the US greenhouse gas emissions, but when you look at across the world, globally, the focus to drive to net zero. So what does that mean? So as utilities and energy providers start going down and need to make investments into what we'll call a data-centric landscape. So organizations are under a lot of pressure to find the right technologies to support data requirements that allows business processes across their businesses to be better improved, right? Industrial organizations know that there's major change that is needed between the geopolitical challenges, increase in costs, supply chain issues, and competition and the distributed workforce. So things have to change, and that's being driven by digital investment and digital transformation. As we mentioned, as this paradigm shift goes forward and how teams need to work together and operational improvements need to be made, digital transformation is key. Information architect, which is really important, is critical as you're driving to make sure that not only are you putting in the right technologies to improve and enable business improvement, but that their quality and that their security of the organization's data. Now, what couple critical things that I feel and we feel that I'm with Aviva is important is the building of industrial information and an industrial information infrastructure. And I break it into two different kind of factors. One is the need for critical infrastructure has operations information, and that's critical, and that's where a digital industrial information infrastructure comes into play. It allows things in the operations environment to ensure asset health, to look at maximizing your resources, improve situational awareness, also helps with improving physical and digital security. So not only cybersecurity, physical security, which we know in the energy industry is critical. Also things like optimizing the maintenance and making sure that asset integrity is there. All of the healthy, safety, and environmental goals are always critical. As we know, safety in the utility industry has always been critical, and it will continue to always be critical. In addition, there's things like, because of what we learned in COVID and with now just from efficiencies, the concept of remote monitoring, more reporting, more analytics, those are all key. And that's all being driven by a very solid and safe industrial information infrastructure. On the other side of the equation is engineering, right? So engineering information is always important. So as you're looking at capital constraints and you're looking at large capital projects, as we know in the industry, how do you make sure that these projects are reliable, on time, and coming within cost or lower cost? Actually turning over the quality of the asset data at handover. So when you go into commissioning and you do go in service, you need to make sure that that turnover of data is consistent and up to date. As we know, change control is always important. Not only is it a key in operating, large assets, it's similar when you're operating IT organization devices, right? So configuration and control. And the actual synchronizing of the data between physical and the systems that are used to reference. These are all critical key points. So a couple of things that as you have that infrastructure in place, that digital infrastructure, first thing I think of when I talk about it is how it enables full visibility and awareness. This helps address the business challenges. As I mentioned, it improves your manpower resource utilization. It streamlines operations across many disparate units. So if you're a large global corporation that has many verticals within it, this allows to help break down those silos. The concepts of digital twins, making sure that they're built and maintained and enabled are critical. And just better insights across the board. Next is, as we know in our industry, there's such large assets, right? So increasing asset performance is very important. You can see the key points there. It's very self-explanatory, but I do want to emphasize that in our industry, and talking about cybersecurity, the key to cybersecurity, right, is protecting critical assets and large assets, not only to protect them, but you want to make sure that they are efficient. If you lose a large transformer, you lose a large generator, you lose a turbine, these are multi-million-dollar investments. And that could be done either because the asset itself is not being properly maintained, but also from cyber attacks with things that Andrew will talk on a little later in this presentation. And as I mentioned, the third is the whole concept of streamlining engineering and capital project execution, right? So it allows to eliminate that inconsistency across silos, faster feed, right? when you break down those silos. Increasing the design, right? Making sure it's scalable so that the whole project team could leverage it. And of course, that data is protected. So as I mentioned already, I talked a little about cybersecurity at a real high level and the life cycle of the regulatory requirements. I just went through what I feel is important is how you put in a digital data-centric industrial infrastructure, which I feel is critical, especially in the energy and utilities organization. Now, I'm going to talk briefly on, as you're putting in that industrial information infrastructure, what I see is 4 key pillars that your organization needs as developing this infrastructure, right? So number one, and I know based on if you're in any part of an organization, when you hear the term governance, it kind of makes you shiver a little. You know, with governance usually comes bureaucracy. Sometimes it's looked at as creating barriers more than efficiencies. But I will tell you, being in this business for 40 years now, it's like any other key foundation of building something, having that proper governance to make sure that the information and the IT policies and the business policies and procedures are in place and aligned. So I always feel that governance is critical. Trust, right? So implementing the cybersecurity practices, you have to trust that employees and that the organization is doing the right thing. Making sure that people understand and are educated, making sure that they understand what the needs and the reasons are for these cybersecurity practices. Management, right? So empowering an organization, making sure that there is the right empowerment there. That's part of the learning experience, but management and oversight involves empowering the organization. And then also just looking at the concept of, and especially in the operational technology world, the OT world now, which has really converged with the IT world so much, is looking not only at making sure you have on-prem systems, but as you move to the cloud and you move to cloud applications, that this, you know, the hybrid architecture is synchronized and being secured also, but there is a need for that hybrid kind of environment as you see more and more cloud applications being developed and maturing. So first, a couple things about compliance is just aligning information to the IT security, right? If you look at the best practices here, I've outlined what I see as 4 of the best practices. Starting from the left, it's just federating, right? Making sure that the corporate identity provider, just looking at that, aligning the IT groups, all right, to the various roles and permissions. So that's a time-consuming but needed, interested issue. Managing asset, you know, software as an asset, right? So that's very important. That's how you move forward and making sure that the applying of those corporate security policies are done. So it's a world of compliance. It's important. The governance helps you focus on how the data platforms could be focused and governed. So next is, as I talked about, that trust, right? And there's trust a couple ways. Trust from an organizational standpoint and trust from the technology and security. This is a little more focused on the technology piece of it, and that's a little of what Andrew's going to talk about. I thought it was important to put this. So when you look at industrial systems, when they're not protected, these are key things that you have to look at for the actual technology trust, right? Security and monitoring, alerting, looking at the network and the domains, security, digital tracing, making sure that data is retained, the right retention guidelines, and protected. So as I mentioned, Andrew will talk more about that in his area. Management, so empowering the organization, right? Looking at things, how do you make it a lower effort? Things as self-service, making as much self-service as possible when you're doing things like password protections and single sign-ons. Lowers your costs. So the more that you start looking at various models, such as subscription models and on-prem, as you look at those things, making sure that you understand how it's securely being managed. So understanding that so you can make your lower cost of ownership. I mentioned single sign-ons already, looking at hybrid models. Those are very important within the management area. And then as you move forward, the more and more that cloud is becoming enabled, and industrial architects, which have primarily been on-prem and OT, and still really mostly are. You know, we are, as I mentioned, the critical infrastructure operators are very conservative, and rightfully, because they are critical infrastructure operators. So they continue to make sure that their on-prem systems are very isolated. And again, Andrew will talk more about that when he starts getting into security. But also just some key things is as you move forward into maybe a hybrid software as a service solution, right? And you look at the various things that are out there. The key is to make sure that the four things I always talk about, right, is first is consistent data quality between both the on-prem and the cloud applications. Data quality is critical, and that's going to be the success, especially as you start looking at AI and ML, machine learning and artificial intelligence. The data modeling concept is critical. Always keeping the secure plant data and the connectivity secure. Looking at how do you manage your plant floor with multiple vendors, staying vendor agnostic, but also being open so that you can bring in new tools from different vendors, give you that option to be able to bring in a new solution, but also make sure that that plant floor is managed and consistent. And then the more that you look at autonomous services, the more that you need to make sure that it's resilient, right? The more that things become autonomous, they have to be safe, secure, and have those checkpoints in there so that you make sure that they're there. So with that, I am going to turn it over to Andrew. And Andrew, it's all yours.
Yes, indeed. Thank you, Bill. So Bill's covered, you know, some of the latest developments in the industry, the latest, you know, pressures the industry is facing. I was going to cover the latest developments in both the cyber threat landscape and the solution landscape, the latest developments there. So let's start with the threats. This is traditional. We always find out first how much trouble we're in. This is from a report on the Waterfall website. If you go under the resources menu, reports and white papers, you'll find the 2023 threat report. What we observe in the, oh, hang on, I missed a slide. What's going on here? Here we go. I was going to give you some examples first and then show you the general trend. The examples are, you know, illustrating attacks on the electric sector. You know, the classic one from 2017, the one that made the headlines, you know, front page of the New York Times was Norsk Hydro, a large power company. They did not have to shut down any of their power plants, which was the good news. The lights stayed on. But they were also a big user of electricity in their aluminum, the aluminum branch of their business. And they did have to cut their aluminum smelters. They basically turned off all the computers in their smelters because they did not trust the cybersecurity of the smelters in the face of this ransomware attack, and had to operate the smelters by hand. good thing. They were able to do that. Their sheet aluminum plants, they said they're so heavily automated, we can no longer operate them by hand, and we're not confident of the cybersecurity program, the way we are on the power gen side. And so they shut down 4 plants. More recently, this was a Russian energy firm hit by Ukrainian hacktivists. The hacktivists did not get into the power plants. They got into the charging stations and reprogrammed the charging stations to, display basically graffiti and disable them so that electric vehicles could no longer be charged. So this is a vulnerability to be aware of. It's not just the heavy iron, power gen, bulk electric system that we worry about, the way that the work NERC-CIP worries about. It's also the distribution systems. If you can cripple distribution, you've crippled the delivery of power. And this is what happened much more recently, same year, last year in Ghana. The ransomware crippled payment systems. Okay, they crippled the IT network, not the power distribution network, not any of the substations. They crippled payment systems. And in this country, a lot of customers prepay for their power. And so they crippled the payment systems. The consumers came up on the end of their prepaid power, and they couldn't buy any more power, and the meters turned the lights off. So again, it shows you the importance of a holistic security program. If physical operations, if the delivery of power has dependencies on the IT network, those systems on the IT network that we depend upon for the delivery of power come into scope for the kind of strong security we have to put in place if we want to keep the lights on. More generally, what we're seeing is in the 2023 threat report, again, on the Waterfall website under resources. This is a report that documents all of the cyber attacks, the deliberate attacks, not errors and omissions, not equipment failures, all the deliberate attacks that caused production outages in any heavy industry or manufacturing since 2010. And we look at trends. So, those criteria, attacks in the public record, in heavy industry or manufacturing, including the power industry, that shut things down, that were deliberate attacks. How many attacks were there like that in 2010? There was 1. It was Stuxnet. How many in 2011? There was 0. There were lots of attacks on critical infrastructure, on the electric sector in particular, but none of them shut anything down. They were either all defeated before they shut anything down, or they were just stealing information. They were not impairing operations. How many were there in 2012? There were 2. One of them was a large power plant. How many in 2013? There was none. So we bounced around 1, 2, none, 4, none. 2018, there was 1. It was a semiconductor fab in Taiwan. 2019, it was 4. That whole decade, 2010 through 2019, cyber attacks that were shutting down physical operations were mostly a theoretical threat. Governments were worried about it. Forward-looking industries and organizations were worried about this threat. But the man on the street was saying, show me the incidents. It's not happening. What we have, the conclusion of the man on the street, what we have in terms of security must be good enough. And then came the new decade, 2019 to 2020. 2020, I think there was 18. 21, there was 23, 22. Last year, there was 57. This year, we're on track for over 100. Most of them are ransomware. The world has changed. We went from, a threat environment where physical impacts were mostly theoretical to a threat environment where physical impacts are doubling, more than doubling, about 2.4x compounded year over year. At this rate, we're going to see thousands of these incidents. If this continues, if this rate of doubling continues, we're going to see thousands of incidents by the year 2027, 4.5 years from now. About 15% of the incidents that we can identify the source for were hacktivists. About 85% of them were ransomware. How does ransomware impact physical operations? Can impact it directly by targeting the automation that controls physical operations. Ransomware can shut things down indirectly. This was the Colonial Pipeline example. Ransomware got into the IT network. The pipeline operator got word ransomware is in the IT network. Protect yourself. And the operator said, what's my procedure book say? It says you have 15 minutes. If that problem isn't solved in 15 minutes, shut the pipeline down. The operator followed procedure and shut the pipeline down. The CEO reported, why is that procedure in place? It's because the pipeline's a safety critical operation. And if there's a risk of contagion, of contamination, of nasty propagating from IT to OT into this safety critical environment, you have to shut it down. The phrase was abundance of caution. There's no evidence that anything got into the OT network, but we had to shut down anyway because IT was down and because we did not trust the strength of our security program to prevent that sophisticated attack leaking into OT. And the third way is dependencies. And this was the Ghana example. If ransomware gets into your IT network and cripples IT systems, and you need those IT systems to keep the lights on, to keep physical operations running, that dependency is going to shut you down. So, this is the world we live in. It gets worse, believe it or not. It gets worse because what we see the ransomware groups, the ransomware criminals doing, the most advanced ransomware criminals are using attack tools and techniques. They're using tools, techniques, and procedures that less than 5 years ago, nation states used exclusively. Okay, these people are cherry picking nation state techniques. This is very bad because a lot of us in the electric utility, in the electric industry, I mean, the big folk in the electric industry know we're targets of nation state attacks. We're strategic targets. The smaller distribution utilities, the smaller generation utilities, a lot of us go, yeah, but we're just a small generator. We're just a small solar farm. We're just a small X. Why would a nation state come after us? The new world is that ransomware criminals are, trailing. They're behind nation states by about 3 to 4 years in terms of their tools and techniques. So that means, what we see nation states doing to each other today, there's a real risk that ransomware is going to be doing exactly the same thing to all of us with money. Do we have money? Yes. Then ransomware is coming after us with nation state techniques. The good news is that we have about 5 years. Now's the time to put some, powerful protective tools in place to address this exponentially rising threat environment. What would that look like? One of the good news in the industry is cyber-informed engineering. This is a strategy that came out of the U.S. Department of Energy, and what is it? I call it security engineering for short. It's engineering. Okay, it's not cybersecurity. Classic example. If let's imagine that every one of us is a technician in a power plant, an old school coal-fired power plant. We have, a 5-story boiler that every one of us is responsible for. We've got 6 of these 5-story boilers in a 1.5 gigawatt power plant. Our job is, to keep these boilers working. We replace the instrumentation when it fails. We calibrate the instruments when they start drifting. We have the gamma ray testers to check the thickness of the wall of the boiler for corrosion. These boilers are our babies. We spend 8 hours a day inside of the kill radius of a worst case boiler explosion. How would every one of us like to be protected against a cyber attack that overheats the furnace under the boiler, overpressurizes the boiler and causes the boiler to blow up? How would we like to be protected against that cyber attack? Would we prefer a spring-loaded valve, where there's a hole in the boiler, and if the pressure is too great, there's a steel plate in front of the hole. If the pressure is too great, the plate gives, the spring deforms, the steam escapes, and there's no explosion? Would you prefer one of these valves, or would you like a longer password on the PLC controlling the furnace? Most of us would like the spring-loaded valve, or 3, please, because these things do wear out. This is this is safety engineering addressing the threat of a boiler explosion. Here's the thing. That engineering solution addresses the threat of a boiler explosion due to misoperation of the furnace, malfunction of the furnace, equipment failures in the furnace, equipment failures in the exhaust, from the boiler. It addresses all causes, including cyber. But where is the overpressure valve in the NIST cybersecurity framework? It's not there. There's no mention of this class of protection in NIST. Where's the overprotection valve in KRITIS? KRITIS makes no mention of it at all. Where is it in NIS2? No mention at all. Where is it in ISO 27001? It's not there. These, where is it in IEC 62443? There's no mention of it. This is an engineering mitigation for preventing physical outcomes of risk conditions, including cyber. It's an engineering mitigation. It's not a cybersecurity mitigation. All of these other things I mentioned are cybersecurity, not engineering. So the important development here is a lot of people. There's a huge community of interest behind this this strategy that came out from Department of Energy and Idaho National Labs. A lot of people are saying we have been applying engineering tools to dealing with threats to public safety, to dealing with cyber threats sporadically. Some of us do, some of us don't. A lot of this is not new. This is an initiative to make that kind of thing systematic, to do it consistently, systematically, across many industries. We call these things engineering grade solutions. What's the difference between a cybersecurity solution and an engineering solution? An engineering grade solution is deterministic. It's mathematically modeled. It's completely predictable. You design a bridge to carry a certain load for a certain number of decades, predictably over the course of those decades. Similarly, we have to design our security systems to carry a given threat load for decades, over the course of those decades, reliably, deterministically, if we're going to protect public safety, worker safety, and national security. The bad news is that this is a strategy. It says we need to develop a body of knowledge. It's not a recipe. It gives a couple of examples, but it does not give a recipe for doing cyber-informed engineering. It says we have to develop a body of knowledge. We have to bring the academics on board to teach engineers the body of knowledge. So it's a strategy, it's a plan, it's a roadmap, not a recipe. Back to the good news, a lot of the stuff that's going to wind up in the recipe, in the body of knowledge, exists already. The second book in the illustration here, Security PHA Review, has been around for 4 years now, and it talks about overpressure valves. It talks about using safety engineering to address cyber threats to public safety and to worker safety. It adds a few steps to the process hazard analysis, or some people call it a HAZOP, adds a few steps to those methodologies to address cyber threats, as well as all of the usual physical threats. Countering cyber sabotage, the subtitle is Consequence-Driven Cyber-Informed Engineering. The book is mostly about risk assessment, but it has a number of chapters on unhackable mitigations. The example they give repeatedly is manual operations in, especially water systems. If you can operate your physical process manually in an emergency, the way that the Ukraine did when the Russians took out, when the Russians erased the hard drives on the computers in their substations. They sent people out to the substations. They unplugged all of the computers, and they took the big lever and they turned the power back on. If you can operate your infrastructure manually in an emergency, it's probably in a less efficient mode, but it's operating. This is a powerful mitigation. And secure operations technology, this is my book from 4 years ago. It takes a different perspective. With safety systems, if an unsafe condition is discovered, what happens? We shut the process down. We return to a safe state. With equipment protection, if we discover a condition that's going to damage our turbines, it's going to damage our transformers, what do? We interrupt the flow of power. We turn the lights off. This is good. We have not killed anyone. We have not damaged our equipment. But in both cases, the lights are off. Secure operations technology is about a methodology to protect reliability critical systems as well as equipment critical and safety critical systems. It is about, a lot of it is about network engineering. It's about preventing attacks getting into the system in the first place so that we can continue operating the system and operating it efficiently using the automation that we've deployed, at such expense over many decades to keep our operations running, to keep them efficient. So network engineering, what is that? It's not a term you can Google. Again, this is an emerging understanding of how to combine engineering techniques with cybersecurity techniques in the world of industrial cybersecurity. Network engineering is primarily about consequence. The example that I give in I am writing a book on this. The example I give in the new book is the difference between a small shoe factory and a large power plant. What's the worst thing that can happen if ransomware takes over a small shoe factory? The machines in the factory, they can't really hurt themselves. If the people in the factory stay outside of the yellow line drawn around each machine saying it's safe to stand here, don't stick your hand across the yellow line, there's no safety threats to the people in the factory. The only safety threat really is if there's a fault in the machine and a technician has to crawl inside the machine to fix it, we need a reliable way to turn that machine off. And so the technicians physically throw a switch turning off power to the machine. They put a padlock on the switch. They put the key to the padlock in their pocket, and now they can crawl into the machine without fear that it's going to turn on because a cyber hacker's got in there. What's the worst case consequence? Well, we're going to lose some money because we have to bring experts in to clean out this mess. We're going to lose some production, and so we have to schedule overtime shifts to make up the lost production. It's going to cost us $5, $10, $15 million. We can buy insurance for that. Do the cybersecurity that the insurance company demands of their policyholders, do it religiously, buy the insurance, and we're good. We don't need really strong security for a small shoe factory. For a large power plant where the worst case consequence is an ammonia discharge into the nearby community, that's a different animal, okay? If the consequence is unacceptable, we need to use engineering grade mitigations to make sure that consequence does not come about. So it's all about consequence. Consequence, the worst case consequence, if every CPU in the entire network is crippled, if every CPU is executing exactly the wrong instructions, what's the worst that can happen? That worst case consequence determines the kind of security that is needed for that network. And in particular, so this consequence concept, again, consequences, the words, if you Google these things, you're not going to find what I'm talking about. What I do when I write these books is I pull concepts together and give them a consistent terminology. But what I'm seeing, if you look at NIRC-CIP and you say, well, what kind of security is demanded by this kind of network or that kind of network, the criteria that NIRC-CIP uses to say this security is needed, that security is needed, that criteria is entirely consequence driven. NIRC-CIP 002 is the standard. Look through, and it's talking all about reliability consequences. You look at the French ANSI standards for cybersecurity for critical infrastructure. They have a complicated formula. They got 3 classes of networks. Almost all of what goes into that formula is consequence. How consequential is it? They don't use these terms, but I think of their class 3 networks as safety critical networks, because pretty much every safety critical network winds up being class 3. The class 2 networks are reliability critical. Keep the lights on, keep the pipeline running. They don't call it reliability critical, they call it class 2. But if you look at the criteria, it's all about consequence. Same thing for the new TS 50701 for passenger rails. It's they got 7 different networks defined, and they explain in painful detail the worst case consequences of compromising each of them and why you're allowed to connect certain networks together, but not other networks because they're too far apart in the consequence spectrum. And this concept of connecting networks with 2 different consequences, this is what we're seeing in other standards. ANSI says, look, you are forbidden from connecting a class 3 network, a safety critical network, to a lesser network, like a reliability critical network. You're forbidden to connect them unless you do it through a unidirectional gateway. If you're connecting a class 2 or reliability critical to a business network, a class 1, you're strongly recommended. The word, strongly is followed by recommended, using a unidirectional gateway, not just a firewall. Inside each of these networks, go wild, use firewalls. They're the right tool for the job. But at these criticality boundaries, we're starting to see you have to do something different. The, TS 50701 talks about criticality boundaries, talks about where you're allowed to connect networks and where you're just not. The TSA rules in the United States, they don't use the word criticality boundary, but they talk about the IT-OT interface. There's a bunch of stuff that they wrote down saying you have to do this at the IT-OT interface and that at the IT-OT because of the colonial incident, because they discovered that this concept of attacks moving from IT to OT is so important. They said a lot about the IT-OT interface, which is the most common consequence boundary. What do we see most common? What's the most common? There's many kinds of network engineering, and I document them in the book that's coming. There's many kinds of network engineering. The one that we see used most often is unidirectional gateways. What is a gateway? If you look at the NIST standards, NIST 882, a unidirectional gateway is defined in the standard as a combination of hardware and software. The hardware is physically able to send information in only one direction. The hardware, if you look inside of the one of these gateways, what do you see? Ideally, what you see is a physical divider down the gateway. You can run your finger down that piece of metal and see visually that there is no cross connect. There's separate power supplies on each side. There's separate circuit boards, completely separate. You've got a fiber optic transmitter, a laser on one side of the board. You've got a fiber optic receiver, a photocell on the other side of the board. And you've got a short piece of fiber on the front. You can send from one side to the other. It's not physically possible to send anything back. There is no laser in the receiving side of the circuit board. This is engineering grade unidirectionality. The software makes copies of servers. If we have a Pi server on the industrial network and we want that data out on the enterprise network, we don't put a firewall in there and start sending messages into Pi and hope that we're not attacking the Pi server through the firewall. What we do is put a gateway in place. The gateway software logs into the Pi server, asks it for all of the latest data, takes that snapshot of data, pushes it out through the strange one-way hardware, and drops it into an enterprise Pi server. And now we've synchronized the 2 Pi servers, generally, to within a couple of 100 milliseconds of each other. This is like a Pi to Pi happening through one-way hardware. Now, all of the enterprise has access to the OT data on the enterprise network. All of the data that's allowed to be shared with the business is out there already in the Pi server or in the cloud for that matter. This is a mature technology. We of course have, 9 ways to work with Pi. Pi is the dominant, historian, cross vendor historian that we see in many industries. We've got connectors. There's connectors in the ecosystem for lots of different kinds of systems. If you need to make a copy of an OPC server so that you can push the OPC data into Pi on the enterprise side, absolutely. There's a ridiculous number of connectors available here. How are these used in power gen? We see Pi servers being replicated. We also see OPC very commonly. OPC DA, OPC UA, OPC HDA, you name it. Whatever your favorite flavor of OPC is, you might have an OPC source in your industrial network, in the power plant, in the DCS network. The gateway, gets the data from the source, typically once a second, but it's configurable. And on the outside, the gateway emulates the OPC protocol. I mean, it doesn't emulate. OPC is an open protocol. The gateway has implemented a standard OPC server, and the enterprise Pi server now interacts normally with that OPC server. The Pi server thinks it's still talking to the OPC server in the industrial network. Everything works. So, this is used very widely in the power sector. Roughly 1/3 of the power generated in North America, I don't have European numbers, but in North America, roughly 1/3 of the power that's generated and pushed into the grid is done through some kind of unidirectional protection. In distribution, there's other options. I mean, what we see most commonly is OPC, data going into an outage management system so that the outage management system can see, can benefit from the insights that we have into our distribution substations. There's another option here I wanted to mention. If you want to send data from an industrial network out to the cloud, for example, to the Aviva Data Hub, you can do it sort of through channels, OPC to unidirectional gateway to OPC to Pi out to the cloud, or you can put a Pi, what's it called, EDS data store, electronic data store,
Edge data store.
Edge, thank you. Edge data store. There's you can put a Pi Edge data store in your industrial network. OMF is an open protocol. You can send the OMF open protocol, through the unidirectional gateway. The gateway understands the protocol, and the gateway on the enterprise side, on the internet side, pretends to be the Pi Edge data store, connects to the data hub, and sends the data to the data hub the way that the Pi Edge data store would have, without any chance of anything getting back in from the internet back into physical operations. A more complicated example is the brain blank, transmission systems. Here, the big risk tends not to be the internet, but connections to partner utilities. In Europe, this happens through 61850. In North America, it happens through ICCP. And the gateways can make copies of ICCP servers, just the way they make copies of OPC servers. So this is, and what we need is, of course, data going out to the transmission system operator on a regular basis, saying, here's what I'm doing, here's what I need, and data coming back in to the peaking plants, saying a little more power, a little less power. And so we're not sending ICCP or 61850 pull requests through one of these gateways and answers through a gateway in the other direction. No, each of them is making copies of servers. There is no connection. There's no back and forth between these gateways. Each of them is truly unidirectional, making copies of servers. It's a more complicated scenario, but there's surprising things that are possible with engineering grade protection at consequence boundaries. A word about Waterfall, if you'll indulge me. We've been around for 15 years. We invented the unidirectional gateway, which is why I care so much about the technology. We are deployed across the world. We're trusted by every kind of critical infrastructure all over the world. Bill, did you want to say a word about Aviva?
Just Aviva. Aviva is a very large company, UK-based. You've heard Andrew talk about Pi, which used to be OSI Soft, which was a privately owned company that was acquired by Aviva 2 years ago. Large industrial automation company, has a large portfolio. We are actually wholly owned by Schneider Electric now. You can see the statistics on the right there, and we'd love to talk to you. So that's it about Aviva. I know we're running out of time. There have been some questions coming in. Andrew, do you want to finish that up first, and then?
It's just, I'm just repeating myself at this point. We've got threats that are driving new regulations. We've got business needs that are driving innovation. We've got to marry the threats and the business needs with new approaches to cybersecurity. Security engineering is an important new approach. We still need cybersecurity. Don't get me wrong. All of the cybersecurity stuff you've heard anyone else talk about in the last 20 years, we still need that stuff. This is the new bit. And, Aviva and Waterfall work together to deliver the very latest innovations, the very latest developments in this space, to customers in the electric sector.
So, Andrew, we're running out of time, but one question that I know you want to answer first right away is, somebody asked this speaker's book's name. So your new book coming out?
Yeah, it's engineering grade OT security.
Okay.
And it's going to launch November 1st. It'll be available on Amazon, but Waterfall gives these things away as a public service. If you want, you can buy it on Amazon. If you send me, we've got basically the fact that you signed up for this webinar means that we're going to start sending you, we're going to send you an email follow-up with a recording to the webinar. And we'll probably start sending you a newsletter like once every 3 weeks. You can unsubscribe anytime you want, but we will also, that newsletter will include, in about 2 newsletters out, will include a sign-up page. If you'd like a free copy of the book, you can go to the page, give your mailing address, and post-launch November 1st, we will send, there's a promotion we're doing for the launch. We'll send out free books for a period of time.
Okay. There was another question which was actually titled "Long Shot Question Around Ukraine Grid. Will the Ukraine grid need to be redone? Different electricity type than Russia?" I will say that actually Urkanago, Ukraine's transmission grid provider, is a customer of Aviva and has been. We actually work pretty closely with them, and as you can imagine with the conflict, definitely there is their plans. That's not really something overall that probably could be talked about right now in general, but
let me add to that.
Go ahead.
Waterfall can't disclose our customers. We play in the security space. Nobody wants anybody to know what anyone's doing security wise. But I will say that I am aware. I know I've heard people from the Ukraine talking about their situation in public, in conferences, and the clear sense that I'm getting is not that they're ripping and replacing and throwing everything out. It's that they're putting some very strong protections in place, and they are very much aware of engineering grade requirements, and they are designing their additions, their new systems to those engineering grade requirements. They are determined to keep the lights on in the face of any kind of cyber assault.
Correct. Same thing. Have heard the same and seen the same at out in public forums. Nothing that confidential stuff. There was another question that we're running out of time. I think we have 2 minutes left. I answered a couple of questions live. There was one about an insurance policy, Andrew.
Yeah, so we can go a little bit over. If people have to drop off, they can drop off. But we're going to go a little bit over with the Q&A, if that's okay with you, Bill. And folks will have the recording link in their mail in a couple of days. And if you want to see the rest of the Q&A, then we can afford to go a few extra minutes.
There was one question, Andrew, earlier. I don't know if you can see the questions that someone asked, if there's examples of what critical cyber insurance companies ask for. Of policies or procedures. I don't know if Waterfall has that or not.
No, I've got some of it. Where to begin? Let me answer the easy part of the question. The answer is it depends. It depends on the company. It depends on the nature of the policy that you're buying. If you're buying a policy for a power plant, you're going to get a different set of questions than if you're buying a policy for your credit card processing system. Okay, they have different requirements. They ask you different questions. What I do is I track unidirectional gateways. The data that I've got is, 5 years ago, the questions from the Lloyd's syndicate, I'll name names, were less than a page for industrial sites. 5-6 years ago. Today, there's 5 pages of questions, one of which is, are you using unidirectional gateways? And I've been talking to the folks at Lloyd's, and I know they're evolving this list of questions, and they have been tracking, they've been participating in the Cyber Informed Engineering Initiative. I know they're tracking this initiative. I will not be at all surprised if in future questionnaires it evolves to say, well, what have you got on the analog protection side? What kinds of consequences are possible? Have you done the analysis? So these questionnaires are becoming much more detailed, in large part because of the risk. Not Petya, shut down a pharmaceutical manufacturer. They suffered $1.4 billion in damages. Zurich, a member of the Lloyd's syndicate, had to pay out $1.4 billion in damages. The regulator for the Lloyd's syndicate said nuts to that. You're no longer allowed. No insurance company in the Lloyd's syndicate is any longer allowed to issue what's called silent cyber. You used to be able to buy a general damages policy that said, if I get hit with any kind of damage, if I get hit with an earthquake and I suffered $3 billion in losses, I'm covered. You used to be able to buy general damages for like billions of dollars. Today, every one of those general damages policies from Lloyd's is required to have a clause that says, we'll cover you for everything except cyber attacks. You're not allowed to roll cyber into general damages or general liability anymore. It's illegal. And they said, if you issue, the rule in the Lloyd's syndicate is if you issue separate policies for cyber, which you're allowed to do, you must cap them at about, I think it's 200 million pounds, which is roughly $250 million. You're not allowed to issue more insurance than that for damages, to physical infrastructure, to whatever, due to cyber attacks. The risk is too high. So here's the lesson. Other insurance companies are looking hard at Lloyd. They've made this change a couple of years ago. I expect to see the rest of the industry follow. Lloyd is a leader in the industry. Here's the thing. If the insurance industry is turning around and saying cyber risks are too great to insure, we cannot insure past a certain level, the risk is too high. If it's too risky for the insurance industry, is it wise for us in the power industry to be accepting those risks and saying, that's fine, we'll do without insurance? If it's too risky for insurance, I suggest it's too risky for the industry. We need to take measures to eliminate the risk. And this is the thing about engineering grade measures. They don't reduce the risk. They eliminate entire classes of risks. The boiler can't blow up anymore because of a cyber attack. It's off the table. So this is, it's a bigger issue. The insurance issue is really a canary in the coal mine kind of scenario, telling us how much trouble we're in.
Right. Well, I think that's our time. And then we answered, I think, most of the questions online. If we have any follow-up questions, I'm sure we will be able to get them back to everyone on the event.
Cool.
Okay, well, thank you, Andrew. Thank you, Bill. That was a great presentation, very informative. Just a reminder to everyone, please take a survey, take a minute and take a survey at the end of the session. It's just 3 questions, but it'll give us that valuable feedback. Once again, on behalf of Waterfall and Aviva, thank you for joining us today, and we'll see you next time.
Thank you, Natalia. Thank you, Bill.
Thank you.
Thank you.